All right, I think we're good. Okay, so 2-1, linear and quadratic functions, where we're going to start in Chapter 2. So Chapter 2, like I said, is all about polynomial functions, but we're going to focus on the linear and quadratic varieties today. If you look in your textbook, don't take it out right now, but if you were to look in your textbook, they do have a definition of a polynomial function that I think might, upon first glance, look a little bit confusing. I'm not going to have you write it in your notes, but I just want to show it to you just so I can kind of explain a little bit about what exactly they're talking about here. So they give you this definition. It says, let n be a non-negative integer and let all these a's, a0, a1, a2, etc., 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 all the way up to an, be real numbers with an not equal to 0. The function given by all of that is a polynomial function of degree n with leading coefficient a sub n. Okay, so what in the world are they talking about there? Well, I'm kind of trying to decipher this a little bit for you here. Do you see how this has a bunch of terms that are all added together here? Okay, they're kind of ugly looking right now, but it's essentially a bunch of terms that are all just getting added together. Okay, and each one of those terms has an a times x to a power, right? And each one of these little a's in front has a subscript. This is a sub n minus 1, and this is little dot, dot, dot here in the middle is etc., 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 until we get all the way down to a sub 2, a sub 1, a sub 0. They use n because we don't know where we start. We don't know how many terms this thing has, because a polynomial could have any number of terms added together. So n, we're assuming, is the first one, and then we're going to count down from n all the way to 0. Okay? But basically, all you need to know is that all these little a's with the subscripts are coefficients. And what's a coefficient? Yeah, it's the number in front of x that you're multiplying by in an equation. Okay? So we have all these little coefficients a. That's what all of these are that it's talking about. Okay? Don't worry about the subscripts. It's just a notation thing to count how many of them there are. So we have a bunch of coefficients, all multiplied by x, raised to some power. Okay? And the powers start at n and also go down, etc., 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 to 1, 0. Okay? So a polynomial function is a summation of a whole bunch of terms where you have a coefficient times x raised to a power, and each one of those terms, that power is decreasing, 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 all the way down to 0. Does that make sense? That's what a polynomial is, kind of in layman's terms. I think it's an easier way to think about it. Something times x to a power, the powers go down. That's a polynomial. Okay? It does make note here at the end, the 0 function, f of x equals 0, is a polynomial function. It has no degree and no leading coefficient. So if the power is 0, the leading coefficient, or the coefficient is 0, it's still technically a polynomial function because it still fits the definition. Okay? It's just that all these little a's then would be equal to what? What would every coefficient be? 0, right? So if every single coefficient is 0, then you have what's called the 0 function, which is still a polynomial. It just has a degree. It has no degree and no coefficient at that point, but it still technically works. Now, the ones that we're going to take a look at, and these we will write down here in just a minute. Okay? We're going to talk about these guys. Okay? The 0 function we just did. There's the constant function, f of x equals just some number, a. A linear function, ax plus b. You guys are probably better suited to mx plus b. You've seen it that way, right? Okay, m is just a variable, though, right? It doesn't have to be the letter m. It could be anything. So we use a and b because they're alphabetical. So ax plus b instead. And then there's the quadratic function, which you guys should be pretty well acquainted with at this point, ax squared plus bx plus c, right? In all of these last three, a is not equal to 0. And the reason that a is not equal to 0 is because if you didn't have that first term there, if this was 0, what would the constant function be? It'd be the 0 function, right? And if a were 0 in the linear function, what would the linear function be? The constant function, right? And same thing with quadratic. If there was no leading term on the quadratic function, there's no x squared in there anymore, then it's a linear function again, right? So the leading coefficient has to exist for us to be able to define them this way. And then there's the degree listed over here as well, which is basically the highest power that you see in the form. Okay. So in our notes, though, let's quickly jot these guys down so that we have them. So the zero function, f of x equals 0, and we'll just quickly list the degrees here as well. Constant, f of x equals a, and, oh, I'm sorry, the degree is not 0 on this one. It's kind of an NA situation. Doesn't have a degree. This one, the degree is 0. Linear, which you guys spent like half of Algebra 1 talking about, is ax plus b. That has a degree of 1. And then the quadratic, f of x equals ax squared plus bx plus c, and that's got a degree of 2. Okay, so, and today, like I said, we're going to focus on those two, okay, linear and quadratic. So, in looking at linear functions, what sorts of graphs do linear functions have? It's not a trick question. Lines, right? We've done tons of these in the past, right? Anything that graphs a line. All right, and there are some important attributes to a line that we will study, and you have studied. And those two things, or the two that you normally are looking for, are the slope of the line and some sort of intercept. Usually the y-intercept is the one that you're given or you're trying to find because that's the easiest to make an equation out of it. Okay, so here's what we're going to do. We're going to analyze a linear function, and I'm going to give you a couple of points that it goes through, and we're going to see if we can then piece together what the slope of the line would have to be, and then because of that, then what the equation of the line is going to be. There you go. Okay, so we're going to say assume f of x is linear and f of negative 1 equals 3 and f of 2 equals 9. And so we're going to develop an equation for f of x. Okay, now this is written in a way that you probably haven't seen before with this type of thing. This f of negative 1 equals 3, f of 2 equals 9. In the past, when you were doing this kind of thing, you were probably just given 2 points. Well, I really did just give you 2 points. I just wrote them in function notation. So if f of negative 1 equals 3, what ordered pair is that? What point is that? It's negative 1, 3. Yeah, okay. So we have the point negative 1, 3, and then 2, 9, right? So the first thing we're going to want to do is to take those 2 points and calculate a slope. Okay, or rate of change is another name for slope. Okay. So I'm going to call it rate of change, just so we're using the new vocabulary here. Okay, so if we get those 2 points, how do we calculate the rate of change, or slope, like we've done in the past? Yeah, Gary.
The x values divided by the difference in the y values?
You're close.
Other way around?
Other way around, right. Difference in the y's divided by the difference in the x. So delta y divided by delta x. If you guys have seen the little triangles before, maybe in physics or something, I don't know. But that basically just means change in y divided by change in x. Okay. So a couple different ways you can think about this. You can go through and subtract the two numbers. 9 minus 3 would be the difference in the y. 2 minus negative 1 would be the difference in the x. I tend to just look at the 2 points and think about counting from one to the other. So, like my change in my y, if I start at 3 and I end up at 9, what's the change? 6. My change in x, if I start at negative 1 and I count up to 2, what's the change? 3. Okay? So, I think it's easier to do it that way, but you can just subtract the two numbers and you got it. So, but in any event, the change in y is 6. The change in the x is 3. So what's our slope? 2. Okay. So we know our slope is 2. So using that, we can start to kind of piece this equation together now. So it's going to be a y equals 2x plus, and I don't know the b yet. So what could I do to find the value of b, given the information that I still have available to me? Yeah?
Put points in for x and y, and then solve the equation for b.
You got it. Take one of those 2 points, plug them in for x and y, solve the equation for b, then you got it. So whichever one is your favorite, doesn't matter. I'm going to take the second one because I don't like negatives. So 9 equals 2 times 2 plus b. So it would appear as though b would need to be 5 to make that work. So my final equation, and I'm going to make it f of x because it's asking for f of x. It's going to be 2x plus 5 would be that equation. Okay, so that's just using our information to help us come up with an equation for a line. And that's about it as far as what they're going to have you doing with lines. As far as the equation side of things, the only thing you're going to have to really do with lines is if we're looking at like a correlation type thing.